Welcome to the session of 8086 microprocessor. In this session, we will go through what are the flag registers in 8086. In the given slide, you can see the complete bit configuration of 8086 microprocessor flag registers. So, on the slide, you can see it is a 16-bit flag register and each bit has the significance. You can see from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 16-bit and each bit has its corresponding flag status. For example, you can see 0 CF, it's a carry flag. U stands for undefined. The second bit is nothing but the parity flag. Fourth bit represents the auxiliary carry flag. The sixth bit represents the zero flag. The seventh bit represents the Sine flag. The 8th bit represents the trap flag. The 9th bit interrupts about the interrupt. The 10th bit will represent the string direction. The 11th bit will represent the overflow. And remaining bits are undefined. Now let us take each bit separately. So SF represents the Sine flag. You can see from the diagram. This flag is set when the result of any computation is negative. So for signed computation, the Sine flag equals to the MSB of the result. So whenever this is indication of the negative or positive signs, in such cases the Sine flag is set. So whenever your computation result is negative in sign, then the Sine flag will be set. Next one is the zero flag. This flag is set if the result of the computation or the comparison performed by the previous instruction is 0. That means if the result is 0, then the zero flag is set or it is set to operation. Next one is the parity flag. The parity flag is set to 1 if the lower byte of the result contains even number of ones. So parity check. So it is called as parity check. So this flag is set to 1 if the lower byte of the results contains even number of ones. Now coming to the carry flag. This carry flag is set when there is a carry out of MSB in case of addition or a borrow in case of subtraction. So this is the significance of the carry flag in flag register. Now coming to the auxiliary carry flag. This flag is set when there is a carry from the lower nibble bit 3 during addition or borrow for the lowest nibble, that is bit 3 during subtraction. So whenever you are performing addition or subtraction operations in the microprocessor, whenever there is a carry, then the auxiliary carry flag will be set for bit 3. Now coming to the overflow flag, this flag is set or raised if an overflow occurs. That means if the result is more than 7 bits in size and if the result is more than 15 bits in size, then the overflow flag will be set or it will be raised. Now coming to the trap flag. This flag is set. It means that the processor enters the single step execution mode. Next one is the interrupt flag. If the flag is set, then interrupts are recognized by the CPU. That means interrupt means a sudden intrusion whenever the program is being executed. That means whenever a program is running, suddenly, if at all there is an interrupt, then this flag will be raised. And there are different types of interrupts: maskable interrupts, non-maskable interrupts, software interrupts, and hardware interrupts. Next one is the direction flag. This is used by the string manipulation instructions. That means whenever there is a string instruction, this direction flag is being raised. If the flag bit is 0, that means the string is processed beginning from the lowest address to the highest address. Otherwise, the string is processed from the highest address towards the lowest address. So, direction flag will give us the information about the direction, how the string is processed, either from lower order to higher order or higher order to lower order. So the sequence will be determined in the string instruction with the direction flag. So these are the flag registers of 8086. So 8086 contain a 16-bit flag registers, and we have discussed what are the various flag registers which are used in the processing of various instructions in 8086.